The moon has captivated humanity's collective imagination since ancient times. Humans have studied it for hundreds of years, first with telescopes, then with robotic probes, even sending 12 American astronauts to the lunar surface. But in many ways, our nearest neighbor remains a mystery.
And so knowing what happened with the moon will help us understand what happened with the Earth, Venus, Mercury, and Mars. And so that's the reason we want to try to understand it. We're trying to understand the past formation of the planets, and so that will help us learn the future.
Clues about our own planet's history and the influence of the moon's gravity on Earth 240,000 miles away could be locked below that dusty lunar surface. The Gravity Recovery and Interior Laboratory Mission, or GRAIL, features twin spacecraft embarking on a challenging mission to map the moon's gravity.
Its sole purpose is to measure gravity of the moon, to try to help us understand how the planets were formed and how they evolved over time.
GRAIL's two spacecraft will fly in formation above the lunar surface to measure the variations in gravity. The mission seeks to reveal clues about our moon's thermal history and how the inner solar system's rocky planets developed. GRAIL is departing from Pad B at Cape Canaveral Air Force Station Space Launch Complex 17. Pre-launch processing and the final countdown are managed by NASA's Launch Services Program at adjacent Kennedy Space Center.
Our team especially gets excited whenever we leave Earth orbit, and going to the moon excites us and it excites the public.
The two spacecraft, called GRAIL A and GRAIL B, are riding into space side by side aboard a powerful Delta II heavy rocket built by United Launch Alliance. It's a rocket with an impressive reliability record.
If we just look at the Delta II rocket, which is the version of the vehicle that we fly today, NASA has a perfect launch record, 48 for 48.
The payload for NASA's most recent lunar mission, called LRO L-Cross, weighed in at 6,600 pounds and was the size of a minivan. It launched in 2009 aboard a massive Atlas V rocket. But that extra performance isn't needed for the GRAIL spacecraft, which together weigh only about 1,600 pounds. Each unit is about the size of a washing machine, designed to be compact and rugged, a perfect fit for the Delta II. Preparing two spacecraft adds an extra challenge to the team's workload, from environmental testing before launch all the way through the countdown.
And then, for instance, on launch day, we have two dedicated teams, one to GRAIL A and one to GRAIL B, and they'll have to individually power up each spacecraft and go through their health checks and put the spacecraft in the proper configuration for launch.
After the climb to orbit, the GRAIL spacecraft will be released from the launch vehicle one at a time as launch controllers and managers on the ground wait for news of spacecraft separation.
So we will definitely wait to celebrate until both spacecraft are safe and on their translunar cruise to the moon.
GRAIL's journey to the moon will take 3.5 months, a mission plan offering plenty of time for controllers to make sure the spacecraft are ready to get to work.
And regardless of when we launch, we're going to have a constant arrival date. So GRAIL A will arrive on New Year's Eve of 2011 and GRAIL B will arrive on New Year's Day of 2012.
Each spacecraft will have to execute a critical 38-minute lunar orbit insertion burn to slide into lunar orbit. Then they'll spend the next 5 weeks reducing their orbit period and getting into formation. During the mission's 3-month science phase, the moon will rotate 3 times beneath the two GRAIL spacecraft as they calculate the gravity they encounter. One spacecraft will trail the other in orbit, and each will slow down or speed up in response to the changing gravitational pull from below.
And you need the two spacecraft to do that in order to measure the distance between the two very precisely.
This data will allow scientists an unprecedented chance to study the gravity of the whole moon, including the far side facing away from Earth, and envision the moon's interior from crust to core. The GRAIL mission also marks the first time students have a dedicated camera on board a planetary spacecraft in order to request photos of specific lunar targets. The Moon Camp project is headed by Dr. Sally Ride, the first American woman to fly in space.
What students need to do is to go on mooncamp.ucsd.edu, and that's how they register to submit images of the moon. And then the images will be put on the internet for the students to see.
At the mission's end, the GRAIL spacecraft will be decommissioned, eventually impacting the lunar surface. The path from the Earth to the Moon has been well traveled in recent decades by pioneers like Surveyor, the Apollo astronauts, Lunar Prospector, and many more. Today, GRAIL is ready to take its place in this long line of lunar explorers.
The moment I'm looking forward to is when we finally get information flying and we're really ready to start taking science data for the mission.
I'm going to be passing Complex 17 about 3:30 a.m. on my way to Console. And that hour of the morning, looking off to the east, seeing the rocket bathed in spotlights, it's an emotional time for all of us on the launch team.
We're standing by now for a weather briefing from our Launch Weather Officer, Dave Kraft, from the 45th Weather Squadron at Cape Canaveral. That will be followed by